Okay, sixth grade, we are continuing along here, getting into our last chapter, chapter 10. And our focus today is going to be on making a stem and leaf plot of the data. Well, a stem and leaf plot is used to divide things up into place values. So we're going to mostly be focusing on the tens place and the ones place. So when we make a stem and leaf plot, we're going to be using this box of information right here, okay? Test scores, various percentages, 77, 78, 87, 75, 58, 72, 85, 77, 70, 80, 55, 81, 59, 71, 52. So when I make a stem and leaf plot, I have two parts. I have what we call the stem, and then we have the leaf, okay? Now, when I do the stem in this case is going to be the number in the tens place. The leaf is going to be the number in the ones place. So I want to put these in order from least to greatest. A stem and leaf plot always puts things in order from least to greatest. So it looks like I have some numbers in the 50s. So I'm going to have one stem of 5. Looks like, which means I'm going to have a 6. And it looks like the highest I go is the 8s. So I can just go with 5, 6, 7, and 8 to make sure I get everything covered. I don't like to skip things. And even though I don't have anything in the 60s here, from what I can tell, I still need to put the 6 because it goes in that sequence 5, 6, 7, 8. Now, in the 50s, it looks like I have a 52, a 55, and a 58. And so since the stem is 5, I'm going to put a 2 to show that there's a 52. I'm going to put a 5 to show that there's a 55. And I'm going to put an 8 to show that there's a 58. I don't have any 6s, so I'm going to leave that row. Looks like I also have a 59. Don't want to forget that. Glad that worked out. So I want to make sure I put the 9 there as well. I don't have any 6s, so I'm just going to leave that row blank. I have 7s. Looks like I have 70, so I want to start with the 0. I see a 71, so I want to put a 1. I see a 72, so I have the 7 and the 2, which shows 72. Then I see a 75, so I want to put the 7 with the 5. And it looks like I've got a 77 and another 77, which means that I'm going to put 2 7s to show that there are 2 77s. And I also have a 78, which means I'm going to put my 8 in there. Okay? Then for the 8s, it looks like I have 80, 81, 85, and 87. So I'm going to have 80, 81, 85, and 87. And then I always like to make sure that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that makes sense because I've got 1, 2, 3, 4, 5, and 3 rows of 5. And so 5 times 3 is 15. So that's my stem and leaf plot. And this represents the number in the tens place. These are the numbers in the ones place. And you'll notice how they're in least to greatest order. That's how I want to do that. I also always include a key in a stem and leaf plot. I put key, and then I put like 7 and 1 equals 71% test score to demonstrate what a number actually means. All right? So that's going to be the first part of your assignment, actually creating a stem and leaf plot given some information. And this is what you need to have, the key, all that. Not too difficult. Now, the second part of your assignment today is actually going to give you a stem and leaf plot like this, okay? And it says the stem and leaf plot shows the numbers of confirmed cases of a virus in 15 countries. So each one of these data set numbers, there's 15 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15. 15 countries, one set for each of the countries. Okay, stem and leaf plot shows the numbers of confirmed cases of a virus in 15 countries. So the first question is, how many countries shown have more than 55 confirmed cases? Well, once again, we look at the key, and it would say, well, if we had a 5 and a 2, which we don't have, but that would mean that there were 52 cases. So we understand that a 9 and an 8 mean 98 cases, or the 7 and the 6 means 76 cases in that country. So how many countries shown have more than 55 confirmed cases? Well, I know all of these that start with a 4 are in the 40s. So those are not more than 55. So I have 51, 53, 54, and 55. None of these are more than 55. 55 is equal to 55, but the question asks us how many have more than 55. So none of these in the 5 are more than 55. The biggest is 55. But then all of these, 63, 64, 64, 68, 76, and 98. That means 1, 2, 3, 4, 5, 6 countries have more than 55 cases. Then it wants me to find these different measures of central tendency: mean, median, mode, range, interquartile range. So I'm going to come over here to my board. I'm going to clear off my original stem and leaf plot to give us some more numbers. And the first thing I want to do is find the mean. So I'm going to look at my numbers here. All right, I'm going to kind of compare these, and it looks like I've got a 42, and then another 42, and then a 44, then a 44, then a 46, okay? I'm going to go ahead and add all those together. 2 plus 2 is 4, plus 4 is 8, plus 4 is 12, plus 6 is 18. Put the 8 down, carry the 1. 1 and 4 is 5, 9, 13, 17, 21, 218. All right, let's go to the 5. 51, 53, 54, 55. 1 plus 3 is 4, plus 4 is 8, plus 5 is 13. Put the 3 down, carry the 1. 5, 10, 15, 20, 21, 213. Well, with the 6, I've got, it looks like 63, 64, 64 again, and 68. Well, 3 plus 4 is 7, plus 4 is 11, plus 8 is 19. So I'm going to put the 9 down, carry the 1. 6, 12, 18, 24, 25, 259. And then it looks like I still have the 76 and the 98. So I'm just going to add those two together. 6 plus 8 is 14. Put the 4 down, carry the 1. 1 plus 7 is 8, plus 9 is 17. Now I'm going to add all these numbers together that I got. 259, 218, 174, and 213. Add these numbers together. 9 plus 8 is 17, plus 4 is 21, plus 3 is 24. Put the 4 down, carry the 2. 2 plus 5 is 7, plus 1 is 8. Plus 7 is 15, plus 1 is 16. Put the 6 down, carry the 1. 1 plus 2 is 3, plus 2 is 5, plus 1 is 6, plus 2 is 8, 864. But I'm taking that 864 and I'm dividing it by 15. Okay, I'm dividing it by 15 because there are 15 numbers in the set. So I'm taking 15, going into 864. I think that 15 can go into 86 5 times. 5 times 15 is 75. 86 minus 75. 6 minus 5 is 1. 8 minus 7 is 1. I like that. That's less than 15. I'm going to bring the 4 down. I'm going to say, okay, 15 can go into 114. I'm going to say 7 times, because I think that 7 times 15 is 105. 114 minus 105 is 9. Cannot end up with a remainder. So I have to add a decimal 0, bring the decimal straight up, drop the decimal down. I believe that 15 can go into 90 6 times, and that would be my final answer, because 6 times 15 is 90. The mean is 57.6. So I come over here, the mean, 57.6. Well, if I want to look at the mode, remember, is the number that occurs most often. So it looks like that I have two 42s. Looks like I have two 44s. Looks like I have two 64s. So there's all of those three numbers, 42, 44, and 64, all appear twice. No other number repeats itself again. No other number shows up more than once. And no number appears 3 times. So it looks like I have 3 modes. That would be 42, 44, and 64, based on my table there. 4 and 2 is 42, and there's 2 of them. 4 and 4, 44. There's 2 of those, and there's 2 64s. So 42, 44, and 64. The median, remember, is the middle number in the set. Okay? So remember what I think here. Well, let's cross off 1 from this end, and 1 from this end, 1 from this way, 1 from this way. And remember what I keep doing. 68, then 1 from this side, then my 64, then 1 from this side, then my 64 again, and then 1 from this side. I'm seeing if I get a clear middle number. Then 63, then the 51 from this side, then the 55, and then the 53, and sure enough, I end up with a clear middle number. That's 54. So my median is 54. Now, the range, remember. Okay, the range is going to be the difference between the highest number and the lowest number. And so I've got 98 is the highest number, 42 is the lowest number. So I'm going to do 98 minus 42. 8 minus 2 is 6. 9 minus 4 is 5. I end up with 56. That is my range. All right, interquartile range. That's the difference between the median of the upper quartile and the median of the lower quartile. Now, I'm going to check something here real quick to make sure. All right. I'm going to make sure here. Now, when we're finding the interquartile range, so I'm going to put them in order from least to greatest, but they already are. So I'm looking first at this first set of numbers, 42, 42, 44, 44, 46, 51, and 53, okay? And I'm thinking, okay, I've got how many numbers there? 1, 2, 3, 4, 5, 6, 7. So the middle number is going to be the 4th number, because that'll give me 3 on one side, 3 on the other side, and 1 in the middle for my 7. So I'm looking for the 4th number. 1, 2, 3, 4. So the lower median, or the lower quartile, is going to be 44. So it's going to be something minus 44. Now if I go to the upper numbers, once again I've got 1, 2, 3, 4, 5, 6, 7. Not counting my median there in that set. So once again it's going to be the 4th number to give me 1, 2, 3 at the beginning, 1, 2, 3 after. My middle one is going to be this 4th one again, 64. So to find the interquartile range, it's going to be 64 minus 44. 64 minus 44 is going to give me 20. And that's going to be my interquartile range. The last question asks, number 3, kind of got this crossed off here. Which data value is an outlier? How does the outlier affect the mean? Well, an outlier, remember, is a number that is far off from the rest of the numbers, and it doesn't matter whether it's higher or lower. When I look at this stem and leaf plot, it seems rather obvious to me that this 8 right here is kind of out by itself, significantly higher than the rest. So when it asks which data value is an outlier, that would definitely be in this set 98. How does the outlier affect the mean? Well, since the outlier is higher than the rest of the group, okay, it affects the mean. It makes the mean greater because it's a higher number away from the rest of the set. So it increases the mean, it makes the mean greater, it raises the average. All right, we'll talk to you later. 6th grade, bye.